or good afternoon or good evening. We're on 11.03 for Algebra 2 today, and we're going to be talking about recursive and explicit formulas for our series and sequences. Just a little heads up about what's coming up in the next couple of classes. This will kind of wrap up the series and sequences, Unit 11 that I'm calling it. And then next class, you guys will have just a review day. So it'll just be a little bit of everything put together. You'll have an assignment, classwork assignment. And then the class after that, you will have a quiz on Unit 11. All right, so for recursion, you have a recursive formula, which means it's a two-part formula. The first part, it's going to give you what your starting value is. So what we've been talking about with our formulas, a sub 1, that's your first term. So it's going to give you that whatever term you're starting at. The other thing it has to give you is a sub n. So as a function of a sub n minus 1. You also could see that as they might give you a sub n plus 1 and a sub n. So again, what all this means is if you have a sub n and then you have a sub n minus 1, if n is 5, let's say, 5 minus 1 is 4. If n is 6, 6 minus 1 is 5. If n is 3, 3 minus 1 is 2. So you're always subtracting 1, which means it's just the term that comes before it. So you're just looking for the one right before it. This is the same thing. This is a sub n plus 1, so let's say n is 1. 1 plus 1 is 2. Here, a sub n would just be a sub 1. So this one is the term before a sub n plus 1. So it's just another way of seeing it, but it means the same thing. We'll talk a little bit. Some of you are going to be good at just looking at this and kind of seeing it, and it makes sense. Some of you are going to have a little trouble. So we're going to try to look at it two different ways. If it's easier for you, you can kind of just figure it out. And if it is harder for you, we'll show you a little bit more concrete way. Let's start with number 1. Given the recursive sequence, a sub 1 is 2 and a sub n equals a sub n minus 1 plus 2. Find the first 4 terms of the sequence defined above. So we know the first term, we know a sub 1 is 2. Okay, so we need 3 more terms. So now I need to find a sub 2. If I want to find a sub 2, that little sub number, because remember this is a sub n, that means n must be 2. So here, n was 1. So now I have n equals 2. So I'm going to sub in a 2 in for my n. So that n here becomes a 2 plus 2. Okay, well, what does that mean? Well, 2 minus 1 is 1. What is a sub 1? Well, a sub 1 is 2. So this is really 2 plus 2, which is 4. So my second term, a sub 2, is 4. Again, if you don't have to sub in the n's every time you do this, I'm trying to make it a little more concrete for those people who it doesn't make quite sense to. But you also could just go through and say, oh, it's the term before. So we'll do that after, and maybe you might be able to look at it that way afterwards. So now we're finding the third term. So n is 3. So I'm going to put 3 in for n into this formula right here. So 3 minus 1 plus 2. Well, 3 minus 1 is 2. So again, I'm taking that term before it. So where is a sub 2? A sub 2 is here. So I'm going to sub that in for my a sub 2, which would give me 4 plus 2, which is 6. Now let's do a sub 4, which means I'm looking for n equals 4. So I'm going to put in a 4 in for n this time. Everything else stays exactly the same. 4 minus 1 is 3. And a sub 3 is 6, we found. So we're going to put the 6 in for a sub 3. and that gives us 8. So a little easier might be if you just always think of a sub n minus 1. So this is another way of doing it. We're done with the problem. If you always think of this as saying n minus 1 means the term before. The term before a sub n. So if I say, okay, well, a sub 1 is 2. And now I want to find my second term. I'm going to take the term that came before it and add 2. So 2 plus 2 gives me 4. For a sub 3, I'm going to take the term that comes before the one I'm working on and add 2 to it. So the last term I did was 4. Just add 2. That gives me 6. And then I want to find a sub 4. So again, I want to take the term before it and add 2 to it. So I'm going to take 6 plus 2. That gives me 8. So my first 4 terms would be 2, 4, 6, 8. Now part B says write an equivalent explicit formula. So an explicit formula is just a general formula. So it's not, so again, a recursive means you're given the first term and then you're given a formula to find the next terms from that. For explicit, you're just given a formula. So I could ask for any value, any term, and you could give it to me. So it's kind of like your term formula that we talked about for arithmetic and geometric. So we're actually going to use those term formulas. The only issue is there are going to be times where a series or sequence is not arithmetic or geometric. It could be exponential. It doesn't have to be one of those two. You don't always have to add to get to the next term or multiply to get to the next term. There's other ways to write out series and sequences. So we have those formulas to use when we're adding and multiplying, and we're going to focus on those ones for this year. But just know that there are other ways, and we'll talk about some other ways of looking at it for it to make sense too. So like for this one, a lot of you may just look at this and say, okay, well, I know to get from 2 to 4, I'm multiplying by 2. So 2 times 2 is 4. It gives me my 4. 2 times 3 gives me 6. 2 times 4 gives me 8. And 2 times 1, obviously, was 2. So if I take 2 and I multiply it by whatever term I'm at, that will give me the new term. So you might be able to just say, okay, well, I know a sub n equals 2 times whatever my n is. Okay, so, and then you're done. If it's not that easy for you, then you might say to yourself, okay, well, I know from this that I am adding 2 to the previous term. Each of these, I did 2 plus 2, 4 plus 2, 6 plus 2. So if I'm adding 2 to each term to get to the next, I know this is an arithmetic. If it's arithmetic, I know my term formula is a sub 1 plus, and this is given to you on your reference sheet, so make sure you look at that reference sheet. You have those formulas handy. All right, so I'm looking for a term formula. My first term they gave me was 2. N, I don't know, I want it in terms of n. And D, what's my common difference? What am I adding to get to the next term? So D equals what you add to get to the next term. Now we did second term minus first term before, but you don't always necessarily know that if you're just given the formulas. Or you could look at your numbers, 2, 4, 6, 8, subtract the second term from the third term, or do second term minus first term. So 4 minus 2 is 2. I know that I'm adding 2 to get to the next term based off my formula as well. And now we can simplify that a little bit. So we have a sub n equals 2 plus, and I'm going to distribute this 2 in. So I have 2n minus 2. Combine my like terms here. These 2's cancel out. And I'm left with a sub n equals 2n, which is the same thing I figured out before. So just a little bit more concrete using those term formulas. If it is adding, use the arithmetic term formula to find the explicit. And if it's geometric, use the term formula. If you're multiplying, use geometric formula to find the explicit formula. Now let's look at another one. The recursive formula is a sub 1 is 18.5, 18.5. A sub n equals a sub n minus 1, so the term before it, plus 1.5. This models the number of people in millions that own a smartphone in the US n years after 2014. Find the value of a sub 5 and explain what it means in the context of the problem. So to find a sub 5, I have to find all the terms that come before it. So a sub 1 I know is 18.5. A sub 2, now I'm going to take 2 minus 1. If I put n in for 2 in for n, 2 minus 1 is 1. So I'm taking my first term and adding 1.5 to it. So I'm taking this term right here and adding 1.5. So that'll give me 20. Now for a sub 3, I'm going to take my term before, so 20, and add 1.5 to that. And I get 21.5. For a sub 4, I take the term I just got, so the term before the fourth term, that's the third term, and add 1.5 to that, get 23. So now the fifth term, I take the term I just got, 23, and add another 1.5 to that, so 24.5. So in terms of the context of the problem, 24.5, that's not just 24.5 people, 24.5 million, because it said in millions, people in just the US will own a smartphone. And it's not in the year 5, right? We said n number of years after 2014. So if we've been 5 years after 2014, that means we're going to be in the year 2019. Okay, so just kind of making it have meaning based off of the problem. And B says write an equivalent explicit formula. So this means I could put in any n value and get out the total. I don't have to find all the terms that come before it like I did with recursive. So to do that, you have 2 options. You can kind of figure out the pattern as to what you're doing. So how many times you're adding 1.5 to your 18.5. Or you might say, oh, I know that I'm adding a 1.5, so I know this is an arithmetic. So I would use my arithmetic term formula. And I'm looking for my first term is 18.5. I want it in terms of n, and I'm adding 1.5 to each number. And you can actually leave it just like that. So you could say a sub n equals 18.5. I'll make it a little nicer, put the 1.5 first. And that's your explicit formula. So again, the other way of doing it is to kind of look at what was happening. So let me just show you another way of doing this over here. So if you said a sub 2 was 18.5 plus 1.5. A sub 3 is 18.5 plus 1.5, which gave you the 20. So that's this right here. And then you're adding another 1.5 to that. A sub 4, you're taking everything you just had and you're adding 1.5 to that. So I'm just writing it out what came before it instead of combining my like terms like I did to get my 20, 21.5, and 23. So then you can kind of look at and say, okay, well, the first time I'm adding 1.5 once. Then the second time I'm adding 1.5 twice. The third time, the a sub 4, I'm adding it 3 times. So that's where this part is coming from here. You're taking whatever term you're at. So if I'm at the 4th term, then I'm going to do 4 minus 1 is 3. I'm going to add 1.5 3 times to my 18.5. Okay, so for many of you, I think the formula might be the best bet, but some of you who it just kind of clicks for and that stuff makes sense, you might be able to jump right to that formula. that one's probably a little bit trickier. All right, let's look at number 3. Determine a recursive definition for the sequence shown below. Be sure to include a starting value and then determine an explicit formula from there. All right, so first let's talk about the recursive definition for this. So we want to write out a formula, and when you do recursive, you have to first state what your first term is. So our first term is 5, and then we want to say how to find the next term after that. So let's look at what's happening here. We're going from 5 to 10 to 20 to 40. So to get to the next term, I'm taking the previous term and doing what to it? Well, to get from a 5 to a 10, I'm multiplying by 2. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. 80 times 2 is 160. So I'm taking my next term, so let's say a sub n, I'm going to take the previous term and multiply the previous term by 2. So that's a sub n minus 1, and I want to multiply that by 2. So if I wanted to find the second term, I would do 2 times 5. That would give me 10. To find the third term, I would take the second term, which was 10, and multiply that by 2. So that would be your recursive definition. Now, if we wanted to talk about the explicit definition, I would say, okay, well, to get to the next term, I'm multiplying. So if I'm multiplying, then I should be thinking geometric. Geometric, my term formula is a sub n equals a sub 1 times r raised to the n minus 1. So if I'm looking for a general formula, I want it in terms of n. My first term is 5. What's my common ratio? Well, my common ratio means what I'm multiplying by to get to the next term. So we took our second term divided by our first term. You could do 80 divided by 40. You could do 20 divided by 10. Or you could do 10 divided by 5. And all of those are going to give you 2. So our common ratio is 2 raised to the n minus 1. And that would be our explicit formula. So if I wanted to find the fifth term, just like we did when we did our geometric series and sequences last class, you would just sub in a 5 in for n and put that right into your calculator. So recursive, you have multiple steps here. You have the first term and then how to get to the next term using the term before it. And then for explicit, it's just a general formula. Now, take a look at if you didn't want to use that term formula. Again, let's just talk about another way of finding explicit without using that formula. You might look at what you're doing here. So the first term is 5. The second term, you're doing 2 times 5, which gives us 10. The third term, we're going to do 2 times 5, which was 10, and multiply that by another 2. The fourth term, we're going to take this whole thing here, so 2 times 2 times 5, and multiply it by another 2. So, and then look at the pattern. Well, this is just 5. This is 5 times 2. This one is 5 times 2 to the second. This one is 5 times 2 to the third. And I would guess the next one would be 5 times 2 to the fourth. And so once you can figure out that pattern, then you could figure out your explicit formula from that as well. So just another way of thinking about it, of how you could figure out that explicit formula. All right, number 4, for the recursively defined sequence, t sub n plus 1 equals t sub n squared plus 2, and t sub 1 equals 2. Find the value of t sub 4. All right, so we know the first term is 2. And so this one's written just a little bit differently. Instead of writing t sub n and t sub n minus 1, it's t sub n plus 1. So it still means the same thing. This is the term that comes before t sub n plus 1. So if n is 1, let's say, we'd have 1 plus 1 is 2, t sub 1 squared plus 2. So this would be t sub 2 equals t sub 1 squared plus 2. So notice right here, t sub 1 comes before t sub 2. And then we'd substitute in. So we know t sub 1 is 2. So 2 squared plus 2 gives us 4 plus 2, which is 6. And now let's continue going a little bit faster. So we'll do t sub 3. We're going to take the term before it, which was 6. And that's going to give us 36 plus 2, or 38. And t sub 4, now we're going to take the term before it. So 38 squared plus 2, and you can put that right into your calculator, gives us 1,446. So that would be your fourth term. So you have to find all of them in order to get to that fourth term. Number 5, find the first 4 terms of the recursive sequence defined below, then write an equivalent explicit formula. So first, let's talk recursive. So our first term is -4. Then it says a sub n equals a sub n minus 1. So that's the term before a sub n, because if this was 2, then this is 2 minus 1, which is 1. And add 5 to it. So I'm going to take the term before, which is -4, and add 5. That gives me 1. Then for a sub 3, I'm going to take the term before, which is 1, and add 5. And that gives me 6. Then for a sub 4, I'm going to take the term before it, which was 6, and add 5, which gives me 11. So now we have our first 4 terms, which would be -4, 1, 6, and 11. Okay, so that is our first 4 terms. Now it says to find your explicit form. So to find our explicit form, we want to figure out, are we adding or multiplying to get to the next number? And in this case, we are adding. So again, you can try to figure it out yourself and see what you're adding each time. But I see that we're adding 5 each time. So I'm thinking arithmetic, which means I'm going to use my term formula for an arithmetic, which I'm given on my reference sheet. So make sure you check it out there. I'm looking for a sub 1, which I know is -4. I want it in terms of n. And I'm adding 5 to get to the next term. And if you didn't know that, then just take 2 terms and subtract them. 6 minus 1 is 5. 11 minus 6 is 5. 1 minus -4 is 5. And then we'll write it out a little bit nicer, put the 5 in the front, and that's it. All right. That's your explicit form. And this one over here is your recursive. Number 6, consider a sub 1 equals 2 and a sub n equals a sub n minus 1 times 3. All right, and generate the value of a sub 4. So we have to go in order. So first, we know a sub 1 is 2. Now we want to find a sub 2. So remember, this is the term before a sub n. So if n was 5, 5 minus 1 is 4. If n was 6, 6 minus 1 is 5. It always comes right before a sub n. So I'm going to take the term that came before, which is 2, and multiply that by 3. That gives me 6. Now I'm going to take the third term. So I'm going to take the term that came before it, which is 6, times 3 gives me 18. Then I'm going to do a sub 4. I'm going to take the term before it, which is 18, and multiply that by 3 to give me 54. So a sub 4 is 54. Write an explicit formula. So again, you could think, how many times am I multiplying by 3? Well, this is 2 times 3. Then I'm doing 2 times 3 times 3, 2 times 3 times 3 times 3, and think about it that way. Or you could say, I know I'm multiplying the term before by 3. So if I'm multiplying to get to the next term, I should be thinking geometric. And if it's geometric, I look on my formula sheet for my term formula, or maybe you have it memorized, and I'm going to substitute in. So I'm looking for my first term is 2. My common ratio, well, what am I multiplying each number by to get to the next? I'm multiplying by 3. Or take 18 divided by 6, that gives us 3. 6 divided by 2 gives us 3. And raising it to the n minus 1. And that's your explicit formula. It's the same as your term formula. You can find any term you want. You don't have to find all the ones that come before it first like you do in recursive. All right, and then number 7 says, so this one's a little trickier. Find the 6th term where a sub n equals 4 times a sub n minus 1 and a sub 3 equals 12. So this one's different because I didn't give you the first term. Gave you the third term, a sub 3. So we want to find the 6th term. So we still have a recursive sequence here, so we still need to use go in order. So we're just going to start at 3. So a sub 3 is 12. So now let's find a sub 4. So a sub n minus 1 means what? That's right. It's the term before a sub n. So now I'm going to take 4 times the term that came before it, which was 12. So that gives me 48. Now I'm going to find a sub 5. So I'm going to take 4 times the term that came before it. So which came before it? 48, which gives me 192. Then I'm going to find a sub 6. So I'm going to take the term that came before a sub 6, was the one I just found, 192, and multiply that by 4. And that gives me 768. So the 6th term would be 768. You also could have, in this case, said, okay, well, I know the common ratio, or said the common ratio is 4, because I'm multiplying by 4 to get to the next term, and then use your term formula, also known as our explicit formula. So then you could have said, okay, well, I know, and in this case, we don't know what our first term is, but you could find your first term by dividing by 4 instead of multiplying by 4. So if 12 is my first term, my third term, then divide by 4, 12 divided by 4 is 3, and then 3 divided by 4 would be 3/4. So you could take 3/4 times your common ratio of 4, a sub n, and then so that would be an explicit formula. And if we're looking for the 6th term, and then 6 minus 1 is 5, and then you could type that right into your calculator. So you do your 3/4 times 4 raised to the 5th power, and that gives you 768. I think that the second way is quite a bit harder, so I would definitely just stick with that recursive formula. All right, and that is it for us for recursive and explicit. Again, that wraps up Unit 11, so you guys will have a review assignment for next class and then a quiz coming up the class after that. And I hope you're all doing well. I miss you guys.